Hello YouTube. Today we're going to perform not an annual maintenance, more of a severe clean, tune, and inspect. This commercial building here, we just took over this account and did a quick inspection. Upon inspection, we found pressures off on almost all of them. Not so much from leaks, but from other issues. There was a bad TXV. One's a little bit low. So, for our maintenance here, since these are three-phase commercial units, we're going to clean all the coils, remove the covers, remove the lids. We're going to acid wash. As you can see, when these covers come off, the pigeon stuff is pretty bad. So we're going to get all that cleaned up, get all the units clean, and then when they're all clean, we're going to all these in. We got new capacitors and contactors all around. So we're going to clean, change capacitors, change all the burning electrical components or all the items like capacitors that are going to fail on what I would call a regular basis, or between 5 and 10 years. And then once they're all clean and up and running, we're going to go through the pressures and adjust that. So, give you guys a little pointer. When you acid wash an indoor evaporator coil, a concern is the water dripping down into the return supply going inside. So, the best way I can find is to actually take your panel and set it here. That way you can spray it without getting stuff inside. This one back together. So on top of cleaning all the coils, during our 10-year maintenance plan, we also swap all the capacitors, whether they're good or bad. We just change them out because in our experience, our weather, our humidity, our heat, these capacitors, I see them fail between every 5 and 10 years. So if you're on a preventative maintenance program, the idea is to stop your trouble before it occurs. So why wait till the capacitor fails? We know it's going to fail 10-year-ish. So let's swap them all out before we lose a capacitor and a motor. Also these contactors, swap those out. So let's do it. Somebody already changed this capacitor or this contactor, so we're going to leave that one. Out of these 8 units, we're going to be changing 4 contactors and all the capacitors. Got me a 7.5 cap over there. Doesn't matter which way you go, just as long as each side is properly the way it was. By itself. What I want you to do is go through and test all the wiring. Make sure it's tight, nothing's loose. Everything, if something was loose, we tighten it. Make sure there's no burning or brittle wires. Feel your wires, because if the wire's becoming brittle, burnt, they usually become brittle first before they snap off. If you don't change wires that are becoming brittle, burnt, they're going to snap off and possibly cause more trouble. So during a preventative maintenance, cut back and replace all burnt or brittle wiring. Usually it's going to be your high volt right next to the contactor. These ones happen to be okay. So, these all look solid. Good.
Yes.
Okay, now that we got the coils clean, we got the capacitors and contactors swapped out. Now we're going to go ahead and check for any, well, we're going to check the windings, we're going to check the insulation on all the wires, on all the pertinent parts. So this one here is reading a caution. So since we got a caution, I'm going to look a little deeper into that one. Okay, so we're good there. Over 1,000 ohms to ground. Good there. Compressor's good. The rest of the system is testing good too. Just for everybody's information, what a grounded compressor is, this leg right here leading to the compressor, basically, as you can see right now, we're energizing power through this red leg here. We're picking it up through the ground, we got nothing. But a grounded compressor essentially is this wire going into the compressor. This insulation is melted off and it's touching the metal. See how now we test bad? So I know that this whole line going in through the windings is good because it's able to take over 1,000 ohms to ground. So essentially we're testing the thickness of the wire, not only outside but inside the compressor. Good. Now we test the contactor itself, which has our condenser motor and everything else hooked up. So we're getting a reading basically on the entire rest of the system, which checks okay. So now that we're confident in our installation of the wires, parts swapped out, coils clean, electrical connections tightened, wires were even cleaned. We don't want any tracking of the electricity, which is these wires, when they become dirty, essentially is a better conductor. The electricity can come through the insulation easier when they are dirty. It's called tracking, I believe. So I didn't really spray it out in the electrical section, but we did clean off all the rest of the wires in the unit while we were cleaning off the acid. So now, once you're confident in your electrical, we're going to put it all back together and go check our refrigeration charge, pressures, superheat, subcooling, and make any necessary adjustments. So what I can see on these units, guys, is my head pressure runs a little bit low. So I'd like to see that about 5 degrees higher, but when I add, subcooling gets a little too far out of whack. So I'm gonna call this good, because suction's good, superheat's good, our subcooling's good. And even though I like to get my head pressure a little higher, all in all, I can't get that higher without throwing off the subcooling. So this is the best we're going to do in this particular situation. So we just got off the phone with the American Standard rep, and I was telling them about all these 8 units with, well, what is it? We got 10 degrees over ambient, 91, 100. You know, it varies. The temperature today is going up and down between 87 and 92. Temperature, the head pressure's staying around 100. Sometimes I've seen it up around 102. So basically we got a 10 degrees over ambient with a 13 degree subcooling, 2.5 degree superheat. The other units had a little slightly lower suction. Superheats were a little bit higher, as you saw, but all in all, we got good we got some superheat, we got some subcooling. We're over 32, so we won't ice up. And so basically we are charged right, but what American Standard said was, with this particular system, that evaporator is so big that when that TXV opens up, it really just floods it. And it does affect the back pressure, the backup on the head. And that's why the heads are getting low. So we were instructed to walk away. And these are good. So this is good according to American Standard. They say don't to be concerned with that. And that's what I was leaning towards anyway, because with a 20 degree split, as you can see there, 20 right on the nose, it's putting out the right tonnage, pulling the right, it's the right BTU, 11.19 on the EER. So, oh, these are running pretty. We're just putting it back together. All coils, indoor and outdoor, are clean. All the capacitors have been changed. 4 of the contactors have been changed. We went through all of the charges, pressures, splits, EERs, superheat, subcooling. One thing we found is these American Standards run at a slightly lower head pressure, and that's okay, because the TXV floods that evaporator and opens so far up that there's just no back pressure to keep the head up. But in fact, subcooling's right on, superheat's on, so we're good.